This is about size exclusion chromatography.
Size exclusion chromatography is based on HPLC technique by utilizing porous particle within the column. Separation happens by differentiate molecule based on size, shape or molecular weight. The column with porous bit have defined porine size. Look at the video. When the dissolved molecule with various size carried by soluble mobile phase flow into the column, the smallest size molecule flow more slowly by penetrating deeps into the pore, while large molecule flow quickly because it does not fit into the pore. Large molecule elated sooner than smaller molecule, while the medium molecule will be elated later than the larger molecule. There are two types of size exclusion. First is gel permeation chromatography. The target is to measure molecular weight distribution of synthetic polymer. The packaging material needs to be hydrophobic stationary phase, while the mobile phase needs to be non-aqueous, which is organic solvent. Second is gel filtration chromatography. The target is to measure molecular weight distribution of molecules soluble in water, which is some natural polymer. The packaging material needs to be hydrophilic stationary phase, and the mobile phase needs to be aqueous.
Now let's talk about the role of calibration. It's to determine the molecular weight of the sample component. This involves a series standard with no molecular weight through the column. The retention time of a standard is recorded and calibration curve is generated. Why is calibration necessary? It's to relating retention time to molecular weight, accounting for a column-specific behavior, and assuring is accurate result. Without calibration, SSCC data would only provide relative size, not absolute molecular weight. Calibration ensures accurate and meaningful result. The key difference between narrow and broad calibration standard in SSCC lies on their molecular weight distribution. For narrow standard, these standards have a very narrow range of molecular weight within a specific batch. It's often chemically different from the sample being analyzed. For broad standard, this standard poses a wide range of molecular weight within a single batch, usually the same polymer type as the sample being analyzed. Both narrow and broad standard have their roles in SSCC calibration. Narrow standard provide a foundation for the calibration curve, while broad standard enhance its accuracy and applicability to specific polymer system. The choice of the standard depends on nature of the sample and desired level of accuracy in molecular weight determination.
The instrument consists of condenser, sample rack, vacuum chamber, GPC column, vacuum pump and GPC pump. Mobile phase reservoir contains the solvent or buffer to transport the sample through the system. Stream pump function like regular stream and deliver the mobile phase through a pulse-free flow. Ensure a constant and precise flow rate of the mobile phase. Injector used to introduce the sample into the flow stream and loaded using an auto sampler. Column, smooth bore glass or steel tubing with thick wall. Column selection depends on size, range and nature of sample. Detectors, the common detectors is UV visible detectors, refractive index detectors, and light scattering detectors, which is a concentration sensitive.
First application of SEC is molecular weight determination, where it can have an average molecular weight and polydispersity of proteins and polymers. It also have a quality control that product can meet a specific molecular weight specification in industries. Secondly is purification of biomolecules, such as proteins, enzymes, and nucleic acids. It separates target biomolecules from contaminants or aggregate by their size. It also have a virus purification that separates virus-like particles and exosome from a smaller impurities. Lastly is a protein complex analysis, where it can identify and quantify protein aggregates, which is critical in therapeutic protein formulation. It also can analyze the quaternary structures, such as oligomeric state of protein.
First advantage, SEC is highly reliable for biomolecules, sensitivity to environmental change like pH or mental on fluctuation. It is fast efficiency and offer high sensitivities and selectivities. For different molecule size, the process is simple, with excellent resolution as buffer composition doesn't interfere, make it easy to use in the lab. Next disadvantage, SEC has limitations such as low resolution for molecules with similar size, broad peaks, and the need of calibration standard. It is also expensive and the sensitivities to environmental factors as test or solution. It requires strict control for accuracy results.